Okay, this is really a lightning talk because I just used a very few time to prepare this. And my project is, I call it ORXSys, which means OpenRISC-based eXtendible system. And it is a working on progress project. It means I didn't finish it and even I didn't publish it or release it. And I'm Alex Gore from Cradle Semiconductor. And about me, I am the embedded system design manager from Cradle Semiconductor, and I'm working on this company for 5 years after the college. And I'm also an open source contributor and a fan, and try to contribute my software code and hardware code. And I have a Master of Engineering grade in EE from Fudan University in Shanghai, and I have actually bachelor degree in computer science. Okay, about my company, it's a fabless, founded in 2008, and we have 3 main products, SerDes, very high-speed SerDes. I believe we can actually be the #1 and #2 in our world. And we have the eXtendible over coax, and also we have high-speed ADC, like just 10 gigahertz, 6-bit, just like this. And we use OpenRISC CPU and MCU in our product for, I think, for many years. Just started from I just start joining the company. And for some of our products, we use OpenRISC to try to fix some hardware issue, because we have some mixed signal circuit, we have some very fast state machine, and we want, sometimes we use MCU to monitor the state machine or some hardware. If we found it have some issue, we try to reset it or try to change some parameter. So, and on the other hand, for some other products, we use OpenRISC MCU to do some network management system things. Just like we can run web server on that, and we can use other like SMP, UART, Tennite way to management our microchip. Okay. So why I try to do this project is, first, I did some research during my Master of Engineering study, because it's a part-time study, and because we use OpenRISC, we want to do more things. So I just use my personal time to do this. So, and the purpose I want to do this is for internal use, for my company use. We want a robust MCU solution for our IC or IP products, because for your tape out is very expensive. We must make everything very stable. So if one thing is work, we don't want to change it. So robust is, or the stability is most important for us. And at the time, I need some platform to do some. Sometimes in company you need to do some tests. You need to do some mini project to try something. So I need a very easy platform, fast development platform to do something. Use OpenRISC CPU. And as an open source project, I think I should take it 2 parts. One, I think there are 2 type of developers. One is just like of you. You know how to write HDL. And you know how to use EDA tools, and so for these people, I want just to provide a very easy to use tool or command line tool for everyone, so you can use OpenRISC very easily. And for other people, I mean, I think the maker movement is rising, and even in China, many people start before they are for doing some internet things, the software engineer, they try to do some hardware things, and there are a lot of maker space, and so the another side, what I just want to do is you may don't know how to write HDL, and but you just have an FPGA board. I just want to provide a platform that you just tell this ORXSys what you want, like you want eMAC, and this board has E5, and or everything you want, and this system will generate everything for you, and you just need to write the software, and even it will generate the RTOS, the device driver for you, and a very simple example for you. So that is what I want. So what I just finished is I am a Pythoner like other speaker, and I use scans to write many building scripts, and I use OpenRISC CPU, both more 1KX and or 1200, and I try them both to let them work, and I try every FPGA board I can get, and I try to use some commercial, some open source, or some vendor provided simulator to simulate the whole thing, and I also tried GCC and LLVM. And for debugging, I tried everything I can use. Okay. So another time, my colleague and I tried to porting a new RTOS. It's some Chinese developer tried to write this RTOS. So this RTOS can provide some. It has kernel object. It has some device object, so I can encapsulation the OpenRISC device with some driver, so it will be more easy to use for later. And I try to other things like some pull request for 1KX. Okay. Just from design flow, it's just a normal design flow, I believe. But there are RTOS driver and bootloader that can load the program from the FPGA board SPI flash after FPGA boot. And also I have board wrapper that each FPGA board has their own wrapper. So how about we just look at this? This is an example, and I think this is what I should talk. There are three parts of this, and the core part, ORXSys core. I think this is the most golden part. You have a CPU, whatever more 1KX or the traditional OpenRISC CPU, and you have debug interface, and you have a boot room and SRAM. And wishbone bus is for external outside here, and I think you basically you don't need to change. You just need to customize it. And for the yellow part, there are a lot of peripherals. Based on what you need, you can change this. You can have two eMAC, or you can have other devices you run. And for the outside, what's outside is a board wrapper. So why I do this is because I hope this part should not be changed for many board. If you have two board and you can use the same part of this into two board. Yes. So and for later use, if these things can work very smoothly in FPGA board, I can just put the yellow part into a very true IC. So I think that make everything stable. And the future work is, I'm working on this in this month, and I try to write an automatic generator system that can generate everything like the construction tool and the bus connections and the RQS and driver. I mean, you have a project descriptor files, and after you provide this, I will generate all of this for you. So you just need to run the construction script, and you can get the final bit file plus the program. And after that, I'm trying to put all the command line to T-code interface, and later is a GUI. So basically that's why. Thank you. And so far, this is not finished part, so I just have some script to do everything that I can generate everything here, but this part is I'm working, so that's, yes, thank you. Any questions?
Richard?
Alex, this is interesting. I missed what you said at the beginning. Where do I get the source for ORXSys? I'd really quite like to have a look at it.
Sorry.
Where do I find the source code? You said
Source code?
Yes, I'd like to have a look at what you've done.
You mean,
Is it online in a GitHub or something?
No, I even didn't publish it for now, because I think until I reach the published status, I don't think it's a good idea to publish it.
I look forward to you finishing.
Yeah, yes. So I'm just trying to fix everything easier and to more software engineer, because I think the software engineer is a very big team, and but the hardware engineer and especially for IC engineer is very small team. So I want to put them to the yeah.
So you've used EXCONs to automate the building of it.
Yes.
I remember, I think Olaf and I were evaluating that a couple of years ago.
Yeah, the FPGA SoC is trying to use some Python code, right?
Yeah, exactly.
Yes.
So can you comment on why you used EXCONs? Is it just because FuseSoft didn't exist at the time, or?
Because I have used for Makefile for a long time and I hate it.
Yeah. I hear you.
And I can show some EXCONs code for building the whole system. Okay, for this, I run this, and they start to collecting every log files and start to synthesize and the PAR and generate bitting file, and then put the ELF files and the bit file together to generate flash files. Then you can burn it to FPGA board. Later, when you boot up the FPGA board, first the hardware start. Then later, the software will be loaded by the bootloader. Then it's just like an MCU. So what I want to do is basically you can use every FPGA board, some standard popular FPGA board as an MCU. Yes, that's. And for I can also use that. Like I have GPIO examination. Oh, sorry. And they start to compile and it generates the file. Yes. And this file can be used for simulation or burn to the FPGA board. Yes. So actually, in last few months, I stopped. I built this, and I have tried this project in my some company project, but I think it's imperfect. It cannot be used by other people because you really need to know a lot of stuff, a lot of things of the whole project. So I'm trying to make it easy. So
Any other questions? No? Alright, thanks Alex. Cheers mate.